Hi, welcome to AP Daily Computer Science Principles, Topic 3.13 Developing Procedures, Video 2. My name is Bradley Bearden, and I teach at Dadeville High School in Dadeville, Alabama. And I'd like to invite you to invite a friend to take computer science. So, what will we learn in today's video? Well, in this video, we're going to focus on why the use of procedural abstraction is important in a program. Why is it important to write these procedures? How does that help me as the programmer? What benefits take place? That's what I want you to get out of the video. Um, and so we have a few definitions here. But I really want you to focus on three there, which is the subdivision of a program into separate subprograms, which is really kind of getting at this idea of abstracting out what this group of code does to make a procedure. So let's get into it. But before we do that, I want to make sure you remember the codes that are involved with a robot. So let's just take a look at an example. So just to remind ourselves how procedures work, let's just look at this problem. We have a procedure call for the procedure update quiz located there on the right. And then that procedure call is assigning the value that's returned to quiz grade. So 74, 35, and 40 are my arguments. And I start out by taking the current score divided by total points. That gives me 0.875. I multiply that by 100. That gives me 87.5. That is higher than the old quiz average. So that grade will be, quiz average will be changed to be 87.5, and the function will return 87.5. So that's our procedure as it is. But there's a problem. Maybe there were some complaints, and the programmer uh, doesn't like this value of 87.5 as the quiz grade. Maybe they don't want any decimal values. They want whole numbers for the grade. So the real question now becomes, am I able to update that procedure below? Are we allowed to make changes to a procedure after the fact? That's really the question at hand here. And then I also want to point out that there is another procedure uh, called round, which takes in the parameter number, and it'll take in that number and it'll return the rounded value. So that procedure basically allows you to round a value. So I'm hoping that I can use that in my procedure. All right. Well, one of the nice things about procedures is when you call the procedure, you don't have to know how it works. You just have to make sure in the call that you put all the right arguments in there and you put the right data in there so it can do what it's supposed to do. But you don't have to know how it works. So that procedure round, we know how to call round, but we don't know how round works. And that doesn't matter. That's fine. So similarly, with update quiz, when we're writing our program call code and then we call our procedure, we don't have to know how update quiz works. We just have to call the right things. We got to put in a quiz average, current score, and total points. So I can update the internals as long as I don't change how update quiz is called. And I don't change what the procedure is supposed to do. So if you look on the right hand side there, you can add in a call to that procedure round, temp average. So that will allow us to round the average. And it will take care of the problem that we had earlier about decimal values being set as the average. So by making this procedure, you got to realize the benefit there is that we can update that procedure as we go and make it better. and we never have to change how that procedure is called in our program code. So that's a huge benefit. So, and just to verify that this works, so I have the same kind of calls there, but on the left, just like before, it was assigned 87.5. But on the right, because we threw in that round statement, the 88 was assigned to the quiz grade. So that's one benefit of working with a procedure, is the ability to update it as we go and not have to change the calls to the program. Let's practice. So here, if you'll notice, each of those columns are supposed to represent the same code segment, but it's kind of like how that code segment was transformed over time. The middle code, the programmer recognized similar code and grouped it together in the same color. And then on the right, they took the similar code from the middle and they turned it into a procedure: detour left, turn corner, and then move forward, move forward. So the question that you need to pause the video and think about, and you may even discuss this with a classmate, is what benefits might the code on the right have over the code on the left? I hope you have a really good discussion on this. Pause the video. Here were some further questions to maybe help with that discussion, to see if we can really try to understand some of the benefits of the code on the right. Let's say, even though it does work right now, it works as we intended. Let's suppose the code did not work as intended. Let's suppose there was an error somewhere. Let's say, let's be specific. Let's say the robot didn't turn the corner properly, and you got to go in and fix it. Which code would you rather work on to debug? The code on the left or the code on the right? Well, if if you know that it's not turning the corner right, you know that if you're on the code on the right, I can just go to that procedure, turn corner, and work on updating that procedure like we talked about earlier. However, if it's the code on the left, I got to go through every single line of code trying to figure out where that mistake is. It's so much to go through. It's much better, that modularity that we talked about earlier, breaking the code up and abstracting out what different parts of the code does, can really help in identifying bugs and errors and fixing those. And another question, let's suppose that I came back to this code, like say 3 months later. That's often something that programmers do. They have to revisit code much later. And a lot of times you'll forget what you did. So, or you're working with someone else that coded stuff for you. Which would you rather look at 3 months later, the code on the left or the code on the right that has procedures written out for you? Well, I'd rather look at the code on the left because I can tell, oh, that's descriptive names again. That's why it's so important. I know what each part's doing. But on the left, I'll have to go back and I'll really have to think, oh man, what was the purpose of this? I may have to go back through it again. It takes a lot of time. So that procedural abstraction really does help manage the complexity of your program. So what should we take away? Well, you should be able to understand and talk about why procedural abstraction is important in managing the complexity of a program, and be specific about some things that it can do, uh, such as helping duplicating code and uh, being able to work on that procedure later. All right. Thank you.